Okay, so here you go. So this one, guys, talks about general information for electrical installation. I want to remind you, I know you finished electrical construction. You are not an electrician until you put your 4 years or 3 years in the field and get your license. This information gears toward safety in the electrical industry. Though we are not electricians, we're not allowed to carry the tools and go work in the electrical panels and so forth. You will be in your career as a designer around many electricians who will open energized equipment while you are with them. I have in many places, guys, as an engineer, I went with electricians. They open the panels for us, modification of a system. So if they want to modify a system, the first thing they do is they invite an engineer or designer like yourself. You go look at the equipment, see, can we modify this equipment? And you're looking at 12,000 amp, 4,000 amp, 1,200 amp panels. So they open it, and here you are taking pictures right through that panel, and you're sticking your head right there when everything is energized. This is why safety is a big deal. So what we'll talk about, guys, as we move on, basic electrical safety. Oops. So that's the major thing that we're going to be doing is basic electrical safety rules. Again, you're not electricians, but you will be working around electrical equipment. So you have to be aware of the safety. Let me see if mine will work here. Okay, so around the electrical safety around the electrical equipment. Um, Access the internet to obtain vital information. Rashad Cooley and everybody else, guys, they will be hiring you to develop a safety training program and a maintenance program for the electricians. And they come to us a lot to do safety training program, arc flash analysis program, and so forth. So you have to be able to get this information from online, a lot of information from OSHA online, put it together in a format and give it to the electricians and say, this is your safety program or this is your maintenance program. And we'll talk about this one in a second here. So these are, just be aware of this. There are, in the electrical industry, there are codes and regulations that you must know. I mean, you can't live without. An FPA 70, this is the Bible when it comes to designing and installing any electrical power system. That's it. You guys are very familiar with that. That's 70. I don't know how many of you are familiar with 70A. 70A is the residential portion of this book. The residential portion of this book. Then 70B, I don't have it with me, I have it at home. 70B is the code related to maintaining the electrical system. When you guys design electrical system in the electrical industry, this system will live 40 to 50 years from today. 40 to 50 years from today when you finish it. Now imagine the poor electricians who are going to be maintaining this power system, 4,000 amp, with hundreds of panels all over, thousands of receptacles, thousands of lighting fixture will be maintained for 40 to 50 years. How are you going to maintain this system safely? The NFPA came up with 70B. It's called 70B. I'll bring it with me one day, I'll show you. Based on this book, you have to maintain the electrical system regularly, like torquing the panels, thermal imaging all your panels, changing the ballast, changing the lamps, and so forth. So that becomes a major, 70B becomes major part. 70E, it talks about working on energized equipment or de-energized equipment safely. You probably heard of 70E. They do a lot of training with 70E. We as engineers and designers, they hire us to be consultant, to consult them on how do you safely create a safety program to work on energized and de-energized equipment. So these are major things. OSHA, of course, the regulations, when you work around electrical equipment, you have to adhere to 70E plus any construction site. That's where it tells you have to put a hat and boots and so forth. And a bunch of others that you have to do. International ICC, that's internet. If you're working overseas, these are the regulations that you have to deal with ICCs and so forth. So we'll talk about these one as we go through. We'll talk a little bit about licensing and permitting and plans and specification in Minnesota and elsewhere. Electrical inspectors and the International Association of Electrical Inspectors metric system. So let's start with electrical safety. Like I said, you guys not electricians, you're not to work. When I say not electricians, by the way, anybody can claim to be an electrician. To be an electrician in the state of Minnesota, you can be two parts. One, licensed electrician, and the other one, registered unlicensed electrician. Two ways. So right now, none of you is a licensed electrician, right? But you could be an unlicensed, registered unlicensed electrician, meaning you have to work under licensed individuals. In Minnesota, and as in many other states, you have to, if you're a registered unlicensed electrician, you cannot work on any electrical system unless you're supervised by a licensed electrician. That's it, done. Master or journeyman. So dangerous voltages in residential. We talk about residential as well as commercial, guys. You have 240, 200 amp. That's enough to send you to the second life if there is an arc flash inside this panel or a short circuit. Shocks that can cause secondary hazard like falling. If you're not working again, and I always used to say residential, we don't do a lot of design, like I said, until I visited with BKV. You can't believe how many, these guys are busy just doing high level apartments. So that you will get it, you will walk into a building, a riser building that has a 3,000 amp service, and all what it feeds is just apartments. 3,000 amp service at 28120. So there's a lot of amps in the residential. Don't think of residential just the house that you're doing with, all the apartments. Fault kind that can cause arc blast. We'll talk about this one in a second. Electrical safety, guys, be aware you're not supposed to work on when they hire you as a designer, you are not electrician. Be aware of that one. You shall not carry the tools. Your company is not licensed, bonded, or insured. So to get you into the electrical work, you have to be an electrical contractor to do this work. Licensed, bonded, insured. So be very aware of that. You don't carry the tools. Though you go to a field, in the field, and they are doing modification and work with equipment, you are with them as a designer or an engineer. So you need to be able to at least advise them, being the engineer and the designer there, on if you see anything that's not safety, it's your responsibility as a project manager when you become project manager to bring it. So that's where we get involved in safety. Number one, our safety. Number two, the safety of the people who work on our project. Two, there's something called lockout tagout procedures. The electrical industry, the rule is you shall not work on any energized object without locking it and tagging it. You're looking at lockout tagout procedure, whereas we don't have a disconnect here. There used to be a disconnect. So you disconnect it, you have a disconnect, you disconnect it, and you lock it with a lock and you tag it with your name. That's the rule for working on any electrical system. The rule. The exception is you work on energized object, energized equipment. The only exception, the only time you are allowed to work on things energized, under two conditions. Condition number one, if troubleshooting this equipment is, you cannot troubleshoot this equipment or work on it unless it's energized. Like I have a magnetic starter and you're troubleshooting a magnetic starter. You can't troubleshoot the magnetic starters unless you energize it. So you can't troubleshoot unless it's energized. That's rule number one. Number two, if de-energizing the object will create more hazard. You're in an operation room in a hospital, shutting down the switch gear to work on it. Can you shut down the switch gear if you're in the hospital and say, well, today send your patients home? So these are the two rules that you can work on energized objects. If you can't troubleshoot them de-energized, and if shutting the system will create more hazard like in hospitals. And it is the law. I mean, OSHA enforces 70E, so what you're looking at is the law. In Minnesota, we adopt OSHA. So if you see somebody working on an energized object, you're violating the law. So be very aware of that. Good housekeeping, when you guys are working on a project, and if you see somebody, for you are not electricians. If you're an electrician, I say it differently. But you work on a project and you see people piling all this good stuff that could be a tripping hazard, your responsibility is to bring it to the attention of the supervisor, their supervisor. You're not their direct supervisor for house cleaning and so forth. So these are for you to become a project manager. There is a term that we call qualified person. Qualified person is the only person that allowed to work on energized objects. On energized object, I can bring my son, the 9-year-old son, and work on an outlet, unenergized or whatever, but under my supervision, But energized object, only qualified people. Here's how they define the qualified people, guys. This is directly from the NEC code. To be qualified, you have to have the skills and the knowledge of the construction and operation of the equipment, and have received training is how to recognize and avoid the hazard. For example, if you've never worked in a solar system, have no idea what an arc flash that comes from a solar panel, you are not qualified even if you're a licensed electrician. Do you guys see anything about licensure here? Nothing. Being a licensed electrician is one qualification. But if you are not licensed, you're registered unlicensed electrician, you work under my license, master electrician, you're qualified if you know how to install a solar system and you know what the arc that comes out of the solar system, how to recognize the energized component and avoid the shock hazard and the arc hazard. As long as you work under my license and I'm supervising you, you're qualified. Any comments, guys? This comes all the time, skills and knowledge. When you're a project manager and you go in the field and you observe something that somebody's doing things that you believe they're not qualified to do, you can pull this from the NEC code book and say, to work on energized object, you have to be qualified. So this will help you manage the project. Again, you're not electricians to work in the field, but this will help you manage the projects that you're working. Remember the word, qualified person. Knowledge, skills, and safety. A couple of things. There is something called, so the rule is you de-energize the equipment safely, lock him, tag him, and then you work on them. That's rule number one. Now, the exception is if you create a more hazard or if you need to troubleshoot the system, you have to do what? Work on them energized. When you work on them energized, you are to have the personal PPE is a big deal. Personal protective equipment. Personal protective equipment, guys, is typically gloves that protect. They're clothes that you put on and gloves and hats and so forth to protect you from two hazards. Number one is the shock hazard, so grabbing on a 4,000 amp energized bus. That's a shock hazard, right? Or the arc flash hazard. Arc flash hazard, you're working on an energized object, you dropped a bolt, you dropped a wrench inside the switchgear, big ball of fire, an explosion happened in the switchgear, big ball of fire happened, and that big ball of fire is going to engulf you. So you need to protect yourself from the blast and the arc flash hazard as well as the shock hazard. So they have rubber gloves, insulated shoes and boots, face shields, safety glasses, hard hats, all these. The job of these is to protect you from being shocked or being burned by the explosion that happened. So be very, very aware of that one. OSHA states employees should provide training. So based on OSHA and 70E, guys, you have to, your employer, so if you are, I know you're not electricians, we're not training you to be electricians, we do on the other end of the aisle, but you're going to be the project manager. So if you are a project manager of a company, work for a person, and you are their project manager, you be aware that your electrician you are to provide a training for your electrician in how to select and use the PPE. So what they do, most of the contractor guys, they hire us at Dunwoody or somebody else to go provide this training for them. And we go through how to select the right gloves, the right shield, the right glasses, the right clothes, category 0 all the way to category 4. And of course, when you work on energized object, you shall not put any jewelries on you. So when you work as an electrician, we're not electricians, so doesn't apply to us. But be aware if you're a project manager again in the field, and somebody's having all these rings and all this stuff and working on energized objects, you might have to tell them to remove them. Anybody knows why? Number one, if you have a metallic object connected to you, it's perfect shock. Number two, what if your ring fall right into a switch gear? Arc flash. You know what an arc flash is? Here's a hot object, and you drop something and you connect the hot object to the frame of the switch gear, say. If you do that, they call it high impedance. High impedance, and a big ball of fire comes out of that switch gear, engulfs you, it could kill you easily. And we lost it done with an apprentice. I don't know if they told you guys when you were here. We lost an apprentice for an arc flash. Worked for People's Electric a couple of years ago. They were working on a 3,000 amp energized. Rule number one, you don't work energized, unless the two exceptions. Bringing the feeder, and somehow they dropped something in the switch gear, big ball of fire. He was not wearing his proper PPE, got burned, died. So it's a big deal. Again, you're not electricians, but you are designers. You are to be in the field. I don't know, do you go to MAC with them? Yeah, so you go all the time. We're all the time if you're in the field around energized objects, all the time.
Yeah, especially if they make conditioning for them. They always make sure that those for us that we're staying away from it.
Absolutely. Absolutely. So even I'm a master electrician. When you worked for Bloom Engineers and we go to work, we were at a place in Hennepin County trying to do some work for them. And the electrician, I did not open the panel because I'm not there as a master electrician. I'm there as an engineer. So we brought the electrician with his PPE, opened the panels for us, went there, took some pictures to modify the switchgear. So be aware of that one. This is a little bit about arc flash. Arc flash, there's two shocks that you can get, guys. Number one is shock hazard. We're very smart. If you're an electrician and you guys are the designer, you're very smart not to touch energized objects. You don't open a panel and grab into phase A and say, now I want to grab into that thing, right? None of us says. The arc flash is when accidentally you drop something into a panel, energized panel, especially 480, 277, and then a big ball of fire, because they call it high impedance short circuit. You have a high impedance short circuit ground fault, big ball of fire comes out of it. That big ball of fire could easily burn you, burn your face, burn your eyes. So that's what the arc flash is. Look at the temperature. The temperature of an arc flash can reach 35,000 degree Fahrenheit, enough to burn any one of us. Um, so this is just a couple of rules if you're working. Um, Assume that if you can, okay, load side of the switch gear. So you guys don't work on the switch gears, but be aware you don't carry the tools. But treat everything as an energized object unless you verify, you as a qualified person verify that's de-energized. So just because somebody said it's disconnected, and you guys don't work on it, but if you are to work on it, you're supposed to verify. How do you verify if something is disconnected? You grab your voltmeter. OSHA said, and 70E say after you disconnect it and lock it, you are to grab your voltmeter, measure line to line, line to line, line to line, line to ground, line to ground, line to ground, no voltage. Now, this piece of equipment is dead. And before you even use the meter, you know what they want you to do? Before you use your meter, you need to go verify that your voltmeter is working. What if your voltmeter is not working? You are to go to a known object, like an outlet. Check your voltmeter. Yup, it's giving me a voltage. Yup, it's working. Then you go check for the voltage. So they want to make sure when you work on energized object, that piece of equipment is completely energized. Respect, I always say, guys, when I've been an electrician engineer for 20 some years, electricity is dangerous, but you have to respect it like everything else. You got to respect it. You got to take it serious. That's all. Arc flash, a couple of things when it comes to the arc flash, guys, and injuries time. Um, if you have an arc flash and the arc flash continues for more than for seconds, the longer the arc flash continues, the bigger the ball of fire gets, and the more engulfed in this fire you will be. Not only a fire, when you have an arc flash, you hear them all the time, arc flash, arc blast. There's first the fire and the heat. What's wrong with the fire? The heat. You could burn with the heat. Then there's also melted copper or aluminum. These are bullets chasing you, right? Explosion. So there's melted copper or aluminum. That's like bullets throwing at you. There's also pressure with that big ball of fire. There's a big pressure wave. What's wrong with the pressure? You're standing on a ladder and somebody pushed you off the ladder. What happened to your neck or your back? Now here goes your neck. You survived. You are not burned, but you broke your back. So so there's another hazard being pushed by the pressure. The third one, guys, is also they have it's very loud, so it could damage your ears, and it's very bright. Here goes your eyes. It could damage the wave, could damage your eyes. So it's a big deal. So that's what they call the arc flash. The code, what's in it for you? A lot of engineering firms are making a lot of money right now doing what we call the arc flash analysis. You guys are doing a lot of arc flash analysis. You walk that building like Dunwoody, take all these panels, do an arc flash analysis. As a result of the arc flash analysis, you are to have, this one doesn't have it, you have a label that says arc flash hazard. On it, there will be the proper PPE that you are to put on if you are to work on this piece of equipment energized. So that's what's in it for you. When you go in the field, solicit business, you tell them that you have by code, by OSHA, by 70E, which is the law of the land, you are to provide an arc flash analysis with short circuit analysis, um, which spits a couple of labels for you. I'll show you later on. You guys want to be doing that with me.
It gives a category.
Yeah.
Before.
You're going to categorize 0 all the way through 4, from 0 to 4. and then and the proper PPE to wear it, from a big suit, category 40 or calorie 40, all the way down to just cotton clothes and long sleeves and glasses. Okay, and you guys will be doing this with me. Next project, you're going to run the short circuit analysis. So we have the software. You're going to enjoy it. Okay, electrical injuries. We have electrical shock. We have electrocution. Electrical shock is you can let go. It shakes you. How many of you guys got electrical shocks? Anybody? I counted at least 20 over the last 20 some years I did. A lot of them are with 220 when I was in Jerusalem, and a lot of them because I was stupid, you know, or arrogant when we were young, especially arrogant or stupid. So shock you a little bit, and if you let go, it's okay. But if you can't let go, then you get into from electrical shock into electrocution. Electrocution, you become a hot dog between a neutral basically and a ground. You're like this bulb here, burning. So it will burn your internal organs, and eventually you join the Lord so fast. Um, the burns, of course, and the falls. The burns, of course, it could be burned into a lot of the current goes right underneath the skin, so it burns you internally. That's the weird thing about the current. So you could look exactly the same if you have, and right underneath it, your organs are damaged. If you have a shock hazard, the fall, you get a shock and you move off and you're standing on the ladder. What's going to happen to you? There you go. You fall off the ladder. You survived the shock, but you broke your neck or your back. So these are, again, you guys are not to carry the tools, but you will be a project manager at one time, and you have to be aware of that one. Okay, steps to take on the event of electrocution. We always do that. The first thing you need to call 911, right? Do not touch. What happens if you touch and energize a human being or object? You can become part of the circuit. You get energized too. If you don't touch the people, call 911, don't touch the people, shut down the power. That's why OSHA lockout, tagout procedures all the time. You're going to go all the way to that emergency push button and bam, this emergency push button and shut down the power. They energize the individual. And perform CPR. If person is not breathing, you're to perform CPR. So that's why a lot of companies, guys, they train their employees on CPR, especially electricians. And time is everything. The faster you remove the energized object from the individual, the more the chances of that individual will survive that shock. Why are we saying this to you guys? You will be the project managers in the field, and you will work, electrician will answer to you, and you better understand this, right? Even if you don't carry the tools, your safety of others will be your responsibility. Okay, using the proper tools, guys, is vital. There's categories of meters, category 3 and category 4. Category 4, this category 4 here, the high fault current, is the only category that you can use on the line side of a disconnect. So when you're doing metering, when using metering, be very aware what type of multimeter are you using. Are you using the multimeter that you guys use with us here in the first quarter? You use this one on the line side, you know what's going to happen if there's a short circuit? That thing explodes right into your face and kill you. The ones that we use in the lab. Fluke, and a lot of them, guys, have good meters. You will see on the category, always look at category 4 or higher. Category 4 or higher. If you have a category 4 or higher, a lot of them have a category 4 or higher. That's the best that you can use. So you can use it on an outlet like this. You can use it in the 4,000 amp switch gear, the load side here, or the line side. The whole idea, guys, if you're using the meter and there's a short circuit right into the meter, there's stories, if you go online, on Fluke website, stories of people dying because the meter exploded while they're taking some measurement, because the meter is not rated to handle the short circuit. So if somebody tells you, here's a meter, go measure, engineer, and you measure some voltage, you verify, and first of all, you should not verify unless you put your PPE. No, use your own meters. Your meter have to be category 4 at least. Okay, and the proper tools. When you work on energized object, there is insulated, fully insulated circuit equipment. Have you guys seen them? You didn't work when you were with us on fully insulated equipment. We don't buy them here. But the plier, if the plier that you're working on is $10, a fully insulated one is $20, double the amount. An insulated meaning that when you grab into that plier, The handle of the plier is fully insulated to handle 600 volt, and they have 600 volt and higher than 600 volt, fully insulated. The ones that we use here, when you guys use with us, they're not. They're comfort grip, they call them. They're just for your hand to feel good. They're not meant to go torque something energized. Um, Training, a lot of training, guys. OSHA has safety training and seminars and bunch of it. Here's a website. You only go there if you become, when you become, I know you guys are going to be, you start as director designers, but eventually you're going to be a project managers. Take advantage of all these training. When you guys with us, I'm sure Karen showed you a bunch of videos about training and all that stuff. So there's tons of, tons of them. But when you become a project manager, you will be putting this training together for companies. So be aware of that. So there's a lot of support from all these. NFPA has tons of information about it. And this is just a couple of compromise. I teach safety. I teach 70E for 3M. I've done it, and Mayo Clinic for their electricians. And when we do that, we take it. Don't take a chance. You have children or you have loved ones that care about you. Your job as a project manager or as an electrician is to go home safe to your family. That's your main job. Is to go safe. I always tell the electrician, your main job is not to finish the job, is to go safe, finish the job. But before that, go safe back to your kids and your family and your loved ones. Which means do not compromise safety. So for what's in it for you guys is you're going to be the project manager who will enforce. When people are working for you one day in the field and you're the project manager, the safety of those people depend on you morally and legally. If you don't care, I hope we all care about each other, right? But if you don't care, it's legal. So meaning you can go to jail if you compromise the people's safety. So that's why follow lockout, tagout, and I'm sure you guys got bombarded, right, Karen? When Karen talked about lockout, tagout, and Steve lockout, tagout, and you get sick of lockout, tagout procedures. Big deal. Big deal. You are to work on equipment and go back home safe to your family. That's what the whole lockout, tagout procedure is. Okay, so that's a few things. Licensing and permitting. So we start always with safety. I know you guys are not electricians, but you must understand this one because you will be project managers, will be design engineers going in the field with the people. You will be, and you're sitting right there and you go with them all the time. So that's a big deal. In the state of Minnesota, licensing and permitting. In the state of Minnesota, guys, here's what the rules are. Most states are the same. Licensing, in order to work as an electrician, hands-on electrician, you have to be licensed, bonded, and insured. Very simple. So you have to be licensed, carry a license as a master or German electrician. You have to be bonded, working for electrical contractor who is registered with the state as a business electrical contractor with a bond, $25,000 bond with the state, and an insurance just in case something happens. A bond will cover you if you come and work on my basement. You did not follow your obligation to me. You pulled out of the job before it's done. I can call the state and pull some of the money that you have with the state as a bond. $25,000 is not a lot. But for most of the people, the jobs, smaller jobs, $25,000 is good enough. Major project, Derek, my friend, what they do, we as an engineer force the contractor to put 10% bond for 10% of the project value as a bond. So if you pull out of it, we will take that 10% and we try to kind of salvage some of the damage that you did, or salvage some money to cover the damage that you did. So bond is a big deal. You have to be bonded, licensed, and insured in the state of Minnesota. When you do electrical work in our state, you are to pull a permit from the Department of Labor. A permit will qualify your work to be inspected by qualified inspectors. That's it. So you guys as a project managers, when you manage your project, when you do estimation with me, when we do project management later on, you're going to keep in mind as you manage the project, well, I'm going to allocate time to pulling a permit, allocate time to make sure that verify the licensure and the bond and insurance of my contractor. Or if you are the contractor, because you guys work for contractors too, and your responsibility is to keep track that you continue with your bond insurance and licensure for your all electricians. Okay. Inspection schedule. So the inspection will get you, like I said, one license. In Minnesota, we don't get too much because you guys, homeowners can pull their own permit in the state of Minnesota on the premises that they own and operate. Okay. So, but construction requirements are provided in construction plans, prints, and drawings. So now you have a license, you permit, but before you do the design the project, before you construct the project, you have to have something called the plans. The plans are the drawings that you guys are going to do with Chad starting next week, and the specification. Plans and specification. They call it spec, plan and spec work. Plan and spec work is you guys are doing it. You're gonna do it with me. Plans, you're looking at the blueprint, set of blueprints, with them a book that thick with detailed description of the equipment that you are to install in this, called specification. You will see them all the time. Um, so prevent confusion and details. So if there's that the last one is really cool. Take preference over the plans. If the specification says you are to use MC cable, and the plan says NM cable is okay, which one rules? The specification. That spec book that we send to the customers rules over the drawing. So if a drafter screwed up, guys, if a drafter screwed up and put a size or something that not right, your specification typically will be reviewed a lot by engineers, so we'll take over. It covers you from lawsuit. Okay, symbols and notifications. I always say, in the electrical industry, mechanical, all our engineering industry guys, we ran out of words to describe what we need to say. You almost can write an essay about designing a power system, a book about designing a power system for a building, right? But who's going to read that book? So because we ran out of words of expressing ourselves, we start expressing ourselves in symbols. That's why symbols are. You grab a big sheet like this, and instead of saying, I want you to put a receptacle 1520 amp, you put a symbol that's 15 amp 120 there. Everybody knows it's 15 amp 120. And everybody understand that this symbol is to represent you installing a box like this with a device inside it and a cover. So these are your symbols on the drawings. ANSI, American National Standard Institute, have tons and tons of standards that we use. Every engineering firm have a standards of symbols. You will get a standard of symbols. Typically, we use Michelle Cooley symbols that we use them here. You guys will get, or some of Michelle Cooley's, you're going to get symbols from me when we start doing in Revit. So when you're not gonna redraw your symbols already done for you. Doesn't mean you can't modify them. These are the symbols they're going to be using. Then with symbols, we have something called notification. Notification, guys, is right next to the symbol you put GFCI. So what does that mean? That's going to be a GFCI receptacle. Right next to it, you can put 72 above finished floor. So meaning this receptacle, I want a 72 above the finished floor. So you put notes next to the devices to give you more information to the installers. We work with the Hallberg engineers. When Paul comes here later on in a couple of weeks, they will be here to introduce a commercial project. He is fond of notes. He writes a lot of notes everywhere. So the more, and his idea is you can't write enough notes. The more notes you write on the plans, the less problems you're going to have when you build your system, because the electrician can read and they don't have to second guess what did you mean. You know, when you design a system, guys, if you think there's different interpretation of what you did, write a note. Keynote it, put a key and write exactly what you should. Look at how much room you have in the drawings. Put a keynote and write it down. So that will save you a lot of hassles. National Electric Code, guys. Safety, and I teach 70 all the time. Safety starts with safe equipment. Equipment, UL. UL will not guarantee you, but will get you, almost guarantee you that the equipment that you're installing is safe. So when you start installing a power system, you need the equipment that you need to install. It needs to be designed by the manufacturer to function properly and safe, right? So here's the panel. Who's going to verify that this panel is supposed to do what it's supposed to do? Square D? Well, it's like what do you call, the fox is guarding the hen's house, right? You can't make the manufacturers guard their own equipment. If you ask me about my electrical work, I'm the best electrician in town, right? but you need a second opinion. So with the second opinion comes UL. So UL, you say, yeah, this is a 4,000 amp switch gear. Yep, take it, put it, and pump into it 4,000 amp, see if it's going to blow up or not. That's why UL becomes a big deal. UL labeling it. Their third-party verification that the equipment will do what it's supposed to do, what it says it's supposed, what the manufacturer says it's supposed to do. So that's number one. Number two, now we got an equipment that's safe and approved it's safe. Then we need to install it, design it safely, and install it safely. That's when the NEC code become your Bible. Now we got a safe equipment. We're going to go design it. You guys come and knowing the code, we're going to design it safely. So we design it safely. Then the electrical contractor, which could be you too, take it and install it safely too. It has to be installed safely, right? So now we have equipment that has been made safe, verified that it's safe, installed, designed safe, and installed safe. Now what's left? 50 years of this equipment sitting in it, right? You install the system, you guys install the building and leave. That building's going to sit there for 40 to 50 years. What do you need to do in equipment when it sits 40 to 50 years? Maintenance. So you need to maintain the system safely. So it becomes there's 70 B. It's called 70B book that tells you that you are to maintain these equipment safely. You are to maintain them so they can continue to function safely. And as you maintain them, you need to work on them energized. So how are you going to be safe when you work on energizing them? Here you go, 70E. See these article? 70E will tell you to maintain them safely. You have to maintain them. Here's what you need to do to maintain them. Now grab your tools, grab your PPE, and work on them safely. And this is what you need to put on yourself to work on them safely. So now we designed a system that can live to 50 years from now, function properly, and safely. That's what you guys are doing. So I always say, as a designer, when you walk in, think of 50 years from now with this equipment function safely. So that's very, very important. NEC, you guys are looking at the NEC, IAEI, those guys, the International Association of Electrical Inspector, every time 2014 is here, by the way, code 2014 is here. I have a copy of the code 2014. I'm not special, I just sign in because I teach the code update. IAEI always, they have a book. I'll show you guys as we get this book that goes through all the changes in the code, analyze them, give them to us as professionals, and we are as a trainers present this information to the public, which is the public to us as the electricians and the other engineers, and teach them what the changes are. So they're really big in keeping up with what's going on in the industry, and you can be a member of them at any time when you guys become big boys and girls. Meaning, more experience in the field. You guys came from the electrical construction. I don't know if you got the 100 definitions you must know before you get into the electrical industry. Did you guys get it with us? There's 100 definitions. If you're in the electrical industry, you got to know. Grounded conductor, ungrounded conductor. I know you know them, guys. Maybe not as 100. Yeah. Yes. Yep, that's it. That's exactly part of it. There's 100, very major, from ungrounded conductor to grounded conductor to equipment grounded conductor to voltage to ground to all this information, guys, in Article 100. The NEC code book, if it's confusing for you, it's one little thing. When I teach you guys the NEC code book, the first major thing that you need to know is the definition. Because later on, you're going to be sizing something called ungrounded conductor. What the heck is an ungrounded conductor? It's the hot conductor, in plain English. So you need to understand what is the equipment grounded conductor versus the grounded conductor. Grounded conductor is the neutral. Equipment grounded conductor is what we call a ground. So you get into the whole terminology. And I will go over as many of them as I can with you guys as we move through. 2011 is with the copy that we use. And also, communities adopt building codes. There are building codes and standards, guys, as designers that you have to be aware of. For example, for energy codes, when you put outlets in an energy code, the outlets that you put in an outside wall have to be energy code outlets, right? You couldn't put any box. The box have to be designed not to allow the air to come from the outside to the inside. That's not an electrical code requirement. That's an energy code requirement, building code requirement. Building code requirement, guys, as you put your switches in a public building, You are to maintain the height of the switches between the minimum and maximum for disabled. The American with Disability Act people, there's called American with Disability Act, require you to put the height of the receptacles and the height of the switches between certain values. Why do you think they do that? That's not NEC code book. NEC code book care less. You can put your switch as high as you want it. There's a limit of 6, 7 on disconnects. But then other codes you have to adhere to. So that's why Mashad Cool and everybody else, guys, the NEC code book, the NEC code, I would say an NEC code book for us engineers, guys, 70% of what we need. Really, 70. What happened to the other 30%? There's other codes that you have to know. But at this time, 70% is good enough. If you know 70, you're cool. Now, as you move on and you become a project manager, you have to be aware of the energy code, the building code, fire alarm code, and a bunch of other things. There's also electrical inspector code for existing building, published by NFPA 73. 73, I've never had a copy of it. That's for existing building. It talks about how to inspect the electrical building for fire and shock and so forth. Remodeling, so anybody have seen it? 73, I've never had a copy of it. But there's NFPA. It's like NEC code book, except it's related to the existing building. Other code and organization, guys, ANSI, IAEI, ICC, all these have a lot of other codes. Like, remember, we're in the 30% now. The 70% is covered with NEC code book for you. Now we're in the 30% only. So put things in perspective. Your job, guys, with me from now until you finish is to focus on that 70%, know it really good. As you go on and we'll throw a little bit on the other, that 30%, but the 70% is what you need to know done with. Then you can add to this as you go. There's one little thing. This is very important. Article 1, Section 110.3. Be carefully. It says equipment listed or labeled equipment shall be installed and used in accordance with any instruction included in the listing or labeling. Let me give you an example. GFCI receptacle. If you look at the listing and labeling for GFCI receptacle, it says it has to be monthly tested. Right? Monthly tested. So then how do you test a GFCI receptacle if you don't have access to it? For example, if you put the GFCI receptacle right behind your plasma TV, and your plasma TV is big, right? So do you really want to go move that big entertainment center and go test it? Now, that becomes your GFCI is not accessible, readily accessible. Now you have violated the listing and the labeling of this equipment, right? Simple. So you take this panel here, listed and labeled to be installed indoor, go put it outdoor in the parking lot. Now you have violated the listing and label of this equipment. So be aware, the listing and labeling is coming from UL. You will have the whole listing, tells you this fixture is listed and labeled to be worked in a dry location. Can I go take that fixture and put it outside and still maintain the listing and labeling of it? No. So that's what the inspector catch you on listing and labeling, even if it's not in the NEC code book. If the listing and labeling does not allow this piece of equipment to be used in these locations, you will get nailed for that one. So pay a lot of attention to listing and labeling for equipment. And the last thing, guys, about this is metric. Metric versus standard. Metric closer than you think. At LB Beckett, when I was there, we were designing based on the metric system for buildings in the Middle East as well as in South America. So you will be required to do calculation based on a square meter instead of square feet. That's why I gave you that calculator yesterday that converts square feet to square meter and so forth. In the NEC code book, guys, they give the information in both square foot and square meter. So if you are, when you work, say you work for LB Beckett and they have a project in South America and based on the meter, don't panic. You can grab this information from NEC code, except you're going to look at different column now. And we do all the time. And you can meet the NEC code book either by doing calculation based on the square meter or square feet. So both of them will meet the NEC code book requirement. So a few things. There's something called National Recognized Testing Laboratories, guys. These are third-party verification. So you say you are the best deer hunter, right? Yeah, and you can say anything about yourself. I need a third-party verification. So give me an organization, respected organization, not Chad Kirdy, respected organization that verified that you're the best deer hunter. Now we say check. Same thing with these. Those are NRTL, very important. UL is notoriously. They're respected organization that can verify what you say is actually what's true, right? Because we can't you can't take the word of the manufacturer about their equipment. That's not enough. Third, check and balance, like in the government, right? You have your check and balance. So somebody have to check on you who has no interest in your product. That's so you're going to hear the National Recognized Testing Laboratory, big deal. UL is notoriously famous of one of them. So it's a third-party verification. Take the equipment. They have factories. They put them. They pump voltages and current into them, blow them up, and see if they can handle the specification that they got from the manufacturer. So if it's 4,000 amp, they put literally 4,000 amp into the switch gear and watch it. For how long? It should, the specifications say for 4,000 amp, it should handle 4,000 amp for 30 cycles, which is half a second. So they work half a second. If it doesn't blow up, within half a second, check, done. If it blows up, within less than half a second, fail. Go back, redesign it. So it's a big deal. So test the equipment and maintain testing it. So from time to time, randomly, they go pick equipment and test it for them. So you get a label from the UL and they can check any of your equipment. So they test them. After they test them and meet the qualification, they list them, they have a list on them, and they give them a label, a UL label, bam. What's your job and I is to look at this UL label for equipment. Does it have a UL label? If it doesn't have a UL label or equivalent, then you have to get me. What happened if you don't have a UL label in Minnesota? You brought a machine from China, doesn't have UL label, which, by the way, Chinese, everybody else knows of UL, so they're smart enough to get a UL label or equivalent. You know what in Minnesota they do? There's a bunch of engineers, registered electrical engineers, that you can hire as an owner if you have a piece of equipment that's not listed. Those engineers will analyze the equipment and they give you equivalent, a report equivalent to the UL. So that's your alternative. Here's UL listing, the label that you're going to do, equivalent. So tested for safety, tested product that meets the safety standards, listed and labeled. The list product must be used and installed properly to assure safety. So they test them, they list them, they label them, and they are to be used according to the listing and labeling. Meaning if it says indoor, you are supposed to use it indoor. UL, CSI is one of them, Canadian Standard Association, Intertech Testing, NEMA. So these are like NEMA 0, NEMA 1, NEMA 3. These are a bunch of these organizations. Any comments, guys? Any questions about these? Comments, questions? So that's basically what this is. For you, what's in it for you when you become a project manager? Be aware of this. That's all what you need to do. I have a couple of pictures I'll show you, and then we'll close that chapter here. Okay, let me see here. So testing, like I said, these meter, be careful if this is category 4 or category 3 as you use the meter. Lockout, tagout, that's how you properly supposed to lock out and tag out the procedures. Exactly, you lock it, you tag it with your name and what you're doing. When you work energized, application for electrical permit, you are to submit an application for electrical permit before you start the job or at the time you start the job. So you send your workers to the field and you go and pull a permit from the state of Minnesota. With the permit, you get here's information about you, about what you're doing, and so forth. So that's in Minnesota and a lot of other states, guys. So power system, a couple of symbols, like I said, you put symbols that couple of GFCI equipment. These are the GFCI, portable GFCI that you can use for safety. White book. If you guys go online, I know you guys still young and there's a lot of, I'll have a white book. I have 2011 that tells you the listing of all the electrical equipment in the NDC code book. And it has a table that references every article in the NDC code book and section to the white book of the UL. So if you have a switchboard and you need to know what the heck is the UL label for that switchboard or listing, how does the UL list this switchboard under which category? No problem. Go to the section that talks about switchboards, panel boards, and you look at that section. Go to the white book. It will tell you this section. Go to this page to find the listing for this section. and it's UL5673 basically, whatever. It will tell you the number of the UL listing for that piece of equipment. So they made it really easily correlate the NEC code book with this UL listing to make it easier on engineers to verify that these equipment are what they say they are. So and it's online PDF free of charge, guys. They give it to you. At least they gave it to me. Okay, a couple of this is just a couple of things you guys are familiar with it. It's called metric designator, trade sizes. Here's the metric designators for conduits that we have. These are names like 12. Nobody uses them a lot. Trade size, let's just say trade size 1 inch is equivalent to 27 squared millimeters. So that's what you're looking at. That's the designate. If you're working the metric system, that's what you're going to be using. This is from the NEC code book. Actual measurement, and and you guys are the one who came from the electrician, familiar with this one. When you say half an inch EMT conduit, that's not the actual size of the EMT conduit. That's a trade name. The actual size is a little bit bigger than that. So it's the trade. So if you take a trade size, half an inch EMT, half an inch rigid, and half an inch PVC, you will find the internal diameter of these conduits slightly different. So, but we call them all half an inch as a trade name. Just be aware of that one. Same thing for knockouts. Here's your multiplier when it comes to converting from metric to use a lot with the metric. Scientific notation. The most important one, guys, we use is K, kilovolt amp, megavolt amp. These are very common, and you can see how many is a megavolt amp, 1,000,000. A kilovolt amp is 1,000. These probably milli is 0.00 is 1,000th. So these are your scientific notation that we use, but the most common ones in the electrical industry that you guys will be dealing with is the mega, the kilo, and the milli. That's probably the most common acronyms. The rest of them is for FYI. Okay, some common measurement of length. This is just conversion 1 inch equivalent to 2.54 centimeters. That's why the converter that I gave you guys, it will be helping you a lot to convert from system to system if you need it. But there's a couple of, you'll find them. DeWalt has them, these converters. I personally use that little calculator that I gave you when I want to convert from system to another. And only if needed. You don't convert it just because. Here you go, conversion and their abbreviation. So if you multiply this number by an inch, you get a meter. What did I tell you guys? That little converter in the field, it's your, this is how we do it mathematically, but I would use the converter. Okay, so that's basically all what I have for you guys. Any comments about this chapter symbol? My expectation from you guys is to read these chapters. You're not going to know everything, but the more you read, the more it sticks in your memory. A lot of this might not apply to you at this moment, but you will remember one day the chat says I'm going to be a project manager, and the responsibility of those electricians are my responsibility safety-wise. That's all. Comments, questions? Okay, so that's all I have for you guys. Shall we have 5 minutes and then I'm going to switch into CAD and we'll start doing CAD?
Sure.
Okay, thank you.